Hey guys, so in this video we're going to have a quick intro just to the idea of increasing and decreasing functions and constant functions. Okay, so mathematically there is I think intuitively this is pretty easy, but mathematically we have like a formal definition for this. And I'm a math teacher, so I've got to just discuss it. So on some intervals, and we'll call those intervals I, this is the mathematical definition of increasing, decreasing, and constant. And I wanted to save my handwriting, so I just typed it out. Okay, so these definitions, they might look very overwhelming. So what this is trying to get at, though, is something that I think you really intuitively understand. And it's very important in math to try to appreciate these things. I know you see these things and then you're just like, math, why is all this jargon and speak and why does it have to be like this? So this is actually a very exact way to explain something. And that really is actually the beauty of mathematics, is that we have such an exact and precise language where, if you understand that language, then you know exactly what it's talking about. So this might look like a bunch of jargon, but what I would challenge you to try to do as you're moving through your higher math classes is try your best to start learning how to decode this language. Because if you can learn to decode technical things like this, it's just going to serve you much better. And even if you never get great at it, just learning to appreciate it, I think it just makes everything better for you. Okay, so what this is trying to get at is, let's say on some interval, so in some part of the graph, as your x's are increasing, so are your function values. So remember, f of x and y are kind of interchangeable. I've talked about this in some other videos. So as your x's are increasing, the outputs of your function are increasing. That's what it means to be increasing. If you're decreasing, that means as your function values are increasing, as your x values are increasing, your y values are decreasing. And then if it's constant, so that means that your function values are always equivalent to one another. Okay, so even if your eyes just glazed over with that, no worries. Okay, let's talk about now the intuitive definition, which is really like with a picture, right? Increasing functions. So check this out, right? As my x's are increasing, right? So we know that on the graph, this is the direction that the x's get larger. Notice the y values are also getting larger in both of these graphs, right? So we have this intuitive idea of what it means to be increasing. It goes this type of direction, right? And then with decreasing, so you can see, again, you can appreciate that very exact language. As the x's increase in value, you can see how the y values are decreasing in value. And intuitively, we just know that this is like the shape of something that is decreasing. So the intuition matches actually the formal mathematics, which is always your goal as you're learning math, is to create intuition. It's a really underrated skill. And then for constant, so it's just constant, right? There's no other shape for this either, right? So with an increasing and decreasing, you could have a line or you could have something that's kind of curved. Same for decreasing, but with a constant function, it actually is just going to be a straight line. So there's nothing to really think about with that. So I just want to practice this idea of increasing and decreasing for a moment, just to kind of help you wrap your head around it. So I've got a couple of examples here that we can just kind of work through, and we just want to determine where they're increasing, decreasing, and constant. Okay, so from here to here, so what are we? We're constant, right? So I'm just going to write constant, and what I want to do is I want to describe in an interval, right? Because that's what the definition said, is on intervals. So using interval notation, where is this constant? Okay, so the best practice with this is to actually use open intervals to describe this. So I know that you can see that this is constant from 0 to 1, but we don't include 0 and 1, and it's because things can be changing. So at this point 1, things could be changing, right? So it goes from being constant to, well, now this is decreasing. So since there's this change, we don't include 1 in the interval notation. Okay, so then where is this decreasing? Well, I start decreasing from here to here, so that's from 1 to 3. And then what does the function do after that? So from here to 5, then it's increasing, right? And so that's really just what I wanted to just really briefly show you in this video. So I have one other example for you. Now, you know me, I always say math is not a spectator sport, so I think that you should just pause and make sure that you've got this, and then hit play when you think you have figured out all the different intervals. Okay, so we're going to start from here to here. We're decreasing, right? Now I have to count this out. So this is negative 1, 2, 3, 4. So I go from here to here. So this is from negative 4 to negative 2 is what that looks like. So I'm decreasing from negative 4 to negative 2. I'm kind of running out of space here. So, okay. Now where am I increasing? So from here to here. Oh, actually, sorry, that looks like more like negative 1. My bad. Let's call that negative 1. So now I'm increasing from here. If you call that negative 1 or negative 2, I guess it's kind of ambiguous, so just be consistent. So from here to here, now I'm increasing. So that's from negative 1 to 0. So from negative 1 to 0, I'm increasing. Then my function goes constant. So I go constant from here to here. So this is from 0 to 1, 2, 3. And then my function starts to decrease again, and it just goes out until forever. So starting at 3 out to infinity, this function now is just decreasing from what we can tell. So how do I add on another interval to this? I use a union sign, right? And then I just go from 3, and that's the positive infinity direction. And so that would be how you would describe that. And so this was just a really quick short video just to kind of introduce this concept to you. When you get into calculus, this becomes a very important concept, so having a little intuition is very helpful. So that's it for this video, guys. I will talk to you next time.